Good day everyone! We are now going to discuss about locating percentiles under the normal curve. The objective for this lesson is the students will be able to compute probabilities and percentiles using the standard normal table. Let's review. Sketch the graph of each of the following and compute the probability. Number 1. Below z is equal to negative 1.96. Number 2. To the left of z is equal to 1.96. Number 3. At most z is equal to 2.58. Number 4. To the right of z is equal to 0.27. Number 5. Between 1.2 and 2.74. Then write the formula for sample z-score and population z-score. Number 1. Below z is equal to negative 1.96. So, z is less than negative 1.96. Below is the graph. The shaded one is the z is less than negative 1.96. So the area there is 0.5 minus 0.4750. So P, z is less than negative 1.96 is equal to 0.5 minus 0.4750. So the probability of z is less than negative 1.96 is equal to 0.025. Number 2. To the left of z is equal to 1.96. So that means z is less than 1.96. So we're going to sketch the graph of it. So you plot in z is equal to 1.96. Then you shade to the left of it. So 0.5 is the left part, and 0.4750 is on the right part. So the probability of z is less than 1.96 is equal to 0.5 plus 0.4750. So the probability of z is less than 1.96 is equal to 0.9750. Next, number 3. At most z is equal to 2.58. So that means z is less than 2.58. So we will sketch now the graph. So the shaded part on the left side is 0.5, then on the right part 0.4951. so the probability of z is less than 2.58 is equal to 0.5 plus 0.4951. So the probability of z is less than 2.58 is equal to 0.9951. Next one, to the right of z is equal to 0.27. So that means z is greater than 0.27. So we will sketch now the graph. So it looks like this. So this one is 0.5 minus 0.1064. So the probability of z is greater than 0.27, that is equal to 0.5 minus 0.1064. So the probability of z is greater than 0.27, that is equal to 0.3936. Last is number 5, between 1.2 and 2.74. So that is probability of 1.2 is less than z is less than 2.74. So we will now sketch the graph. So in this one, the area is 0.4969 minus 0.3888. So the probability of 1.2 is less than z is less than 2.74, that is equal to 0.4969 minus 0.3888. So the probability that z is between 1.2 and 2.74, that is equal to 0.1081. Write the formula for sample z-score and population z-score. Sample z-score is z is equal to x minus x bar over s, where z is the standard score, s is the standard deviation of the sample, x is each value in the data set, and x bar is the mean of all values in the data set. Population z-score, z is equal to x minus mu over the standard deviation, or the sigma. So mu is the mean and sigma is the standard deviation. Which of the following expressions are familiar to you? First honor, top 5, a score of 98%. These are known as expressions of order. Percentile. It is a point in the distribution such that a given number of cases is below it. It is a measure of relative standing. It is a descriptive measure of the relationship of a measurement to the rest of the data. Three important things to remember when we are given probabilities and we want to know their corresponding z-scores. Probability value corresponds to an area under the normal curve. In the table of areas under the normal curve, the numbers in the extreme left and across the top of z-scores, which are the distances along the horizontal scale. The numbers in the body are areas or probabilities. Z-scores to the left of the mean are negative values. Let's find the 95th percentile of a normal curve. So 95% is the same as 0.9500. So let's split 0.9500 into 0.50 plus 0.45. Refer to this table of areas. Locate the area 0.4500 in the body of the table. Oh no, it's not found in the table. It is between 0.4495 and 0.4505. Find z by interpolation. Find the z-score that corresponds to 0.4500 in the leftmost column. So, find the z-score that corresponds to 0.4505, which is z is equal to 1.65. That is by using the table of values for z-scores. Then find the z-value that corresponds to 0.4495. So z is equal to 1.64. Then find the average of the two z-values. So z is equal to 1.65 plus 1.64 divided by 2. So z is equal to 1.645. So yes, the 95th percentile is z is equal to 1.645. Let's shade the region to the left of z is equal to 1.645. So yes, the shaded region is 95% of the distribution. Let's find the upper 10% of the normal curve. Express 10% as probability, which is 0.1000. Then, using the upper side of the mean, find the remaining area. So 0.5000 minus 0.1000, which is equal to 0.4000. Then let's refer to the table of areas under the normal curve. Locate 0.4000. The area is not found in the body of the table, but we can take 0.3997, which is its closer value. Find the z-score that corresponds to 0.3997. So that is z is equal to 1.28. Let's now make a sketch of the curve. So here it is. The shaded region is the upper 10% of the normal curve. The results of the nationwide aptitude test in mathematics are normally distributed with the mean, which is 80, and the standard deviation is 15. What is the percentile rank of a score of 84? So analysis. Since we are interested in the percentile rank of 84, this means finding the percentage of scores below 84. So we are going to transform 84 into a z-score form, then perform the appropriate mathematical operation. Convert the row score of 84 to z-score form. So z is equal to x minus mu over sigma. So that is 84 minus 80 over 15, which is equal to 0.27. Let's now plot z is equal to 0.27, then shade the required region. Then, get the total area below z is equal to 0.27. Examine the required region in the sketch of the normal curve. So that is 0.5000 plus 0.1064, which is equal to 0.6064. The percentile rank is equal to 0.6064 multiplied by 100. So that is 60.64%. References from Belicina Rene R. and Elisa S. Bacay and Efren B. Mateo, 2016, Statistics and Probability, Quezon City, Rex Bookstore. And here are the photo references. Thank you very much for watching and listening. Subscribe to Analyze Math.